Yeah, good day viewers, welcome to my channel. This is Radical Science. If today is your first time visiting my channel, all I want you to do is to hit the subscription button and also turn the subscription bell on so that anytime we post in this channel, you can be able to get notification to enable you watch our videos anytime we post. So on today's edition, I'll be taking you on 2025 NECO chemistry practical. So all you need to do is just to pay attention to this video because I'm going to be taking it step by step. And remember, if you have not subscribed to this channel, kindly hit the subscription button so that you get notification anytime we post in this channel. So okay, we are asked to provide 150 cm cube of trioxonitrate 5 acid solution in a bottle labeled A. The solution, which should be the same for all candidates, will contain 6.3 cm cube of concentrated trioxonitrate 5 per dm cube of solution. Now on the B, it says 150 cm cube of mixture of sodium trioxocarbonate 4 and sodium trioxonitrate 5 solution in a bottle labeled B. The solution, which should be the same for all candidates, contains 5.5 grams of sodium trioxocarbonate 4 and 2.5 grams of sodium trioxocarbonate 5 per dm cube. So now what this simply means is that we are going to dissolve 6.3 cm cube of concentrated trioxonitrate 5 in 1 dm cube, which is a 1000 ml. You're going to use a distilled water, dissolve this particular value, which is 6.3 cm cube, in 1000 ml of water. Okay, you dissolve it in 1000 ml of water or in 1 dm cube. Have it in mind that 1 dm cube is equal to 1000 ml. So that is what we are asked to do here. So on this video, I will give you guidelines on how you can be able to produce that 5 solution in a bottle labeled B, which means this trioxocarbonate 4 should be dissolved with sodium trioxonitrate 5 solution in a bottle, which is in 1 dm cube. Now each of these substance should contain, for example, that of sodium trioxocarbonate 4 should contain 5.5 grams of that, while the sodium trioxonitrate 5 should contain 2.5 grams of this. So that is what you should do. You just mix the both of them together and dissolve it in 1000 ml or in 1 dm cube. So that is what you are expected to do. So let us now proceed on how you can be able to do that. Here we have already prepared our 1000 ml, which is 1 dm cube of solution A. Okay, so if you want to learn how to prepare this, all you need to do is check my other videos. You will see process which I use in preparing most of these reagents, because every year when I carry out these practicals, I will always show you how to prepare it. So if you want to learn how to do it, all you need to do is just to go to other videos on chemistry titration and see how it is prepared, or you can just chat me up using the phone number on the screen and I will give you guideline on how to prepare this. In this flask, okay, so okay, so we're going to be leaving it at 0.00. So here we are going to pipette our solution B. have it in mind, you first of all rinse all these equipment before you begin your titration. So this is our metal orange. Just put I'm putting just 2 drops. So we'll begin to type. First titer is giving us, that is the final, it is giving us 26.20. Okay, so 26.20, and here under the volume of the acid we will now have 26.20. Okay, our second titer. So now let's still put it 0.00. Okay. So from here we got 26.1. Okay, so 26.10. So our final becomes 26.10. Okay, so that is, by the way. Now let us put our initial here, 0.00. Okay, so that is, let's now continue with the third titer. We've gotten our first titer, second titer, and then we are going over to the third titer. Okay, now having done that, our third title, which is our final reading, is 26.20. Now the volume of the acid is now 26.20. 0.20. Okay, so that is, by the way. Now let us look at our average volume of the acid. So our average volume of the acid now will now become 26.20 plus 26.10 plus 26.20 divided by 3. So we divide it by 3. Or we divide by 3, it will now give us 26.20. So that becomes our average volume of the acid used. So the average volume of the acid used in this reaction becomes 26.20. 26.20. So that is that for now. So let us continue on other possible questions that you will likely see on this particular titration. Then we now have H2O plus CO2. Okay, so this is our equation for reaction. This is our equation for reaction. So take note.